Alright, so for this screencast, we're going to do some viewports. I'm going to do edit, view, test, and create it. So for this example, I'm going to plot a trajectory of a ball in 3 dimensions. So I'm going to say v equals 20. I'm going to say the azimuth is 45 times pi over 180. I'm going to say the elevation angle is 45 times pi over 180. So Vz is v times sine of the elevation angle. V2d is v times the cosine of the elevation angle. And then Vx is v2d times sine of the azimuth. And Vy is v2d times the cosine of the azimuth. And then I'm going to say t equals, and I'm just going to do an arbitrary number, 0, 0.1 to say 10, right? And then x is, I'm going to say x0 is 0, y0 is 0, z0 is 0. So x is x0 plus vx times t, y is y0 plus vy times t, z is z0 plus vz times t plus 1/2 times az times t dot hat squared, and az is negative 9.8. Alright, so now if I do plot 3 x, y, z, I should get trajectory through the air. It doesn't look like it hit the ground yet, so let's add 15 seconds. Let's throw a grid in here. And at the top, let's throw a close all, CLC, and a clear. Alright, so there's my trajectory. Oh, it actually looks like I went through the ground, so I went way too long. So let's do like 2 seconds. Okay, that's better. Alright, now, while I'm rotating this, notice that here in the bottom left, so see in the bottom left it says AZ colon negative 46 EL colon 16. So that's the viewport angle. So as I move my cursor around, notice that AZ and EL change. So if I want a specific view right when the graph pulls up, say I want it to pull up at negative 2018, I would come down here and I would do view negative 2018. And now when it comes up, notice that it's right at negative 2018. If I change this to say positive 20, notice that the graph is now in a different orientation. I can go all the way to 90. Notice that now it's 2D. And there you go. So now you can change the viewport angle to whatever you want.